Hello there. Okay, this is a continuation of part one of the quadratic equations. I have to recommend you to complete part one before we proceed this part two. These quadratic equations which we have encountered in factorization techniques are all rational solutions, easy to get two numbers in which their product is this much and their sum is that much. That's easy. You can analyze two numbers in which their product is a specific value as well as sum. This is called a technical factorization, which we have covered it in the previous lesson. But now we have another technique of solving quadratic equation, which is completing the square technique. Completing the square technique is an important technique, and it can solve any kind of quadratic equation. And even the general formula for quadratic equations is derived from this technique of completeness squares. It's not only that, in some cases you find questions of asking the sum of roots of a given quadratic equation, the product of the roots of a given quadratic equation, and also the average of the roots of a given quadratic equation. You can simply find out these things without getting the roots at hand using a certain formula. That in this we are going to discuss it in here. Uh, the first part, which is factorization technique, helps us to find out rational solutions only. That was limited one. But in this technique, we can have irrational solutions and even non-real complex solutions to solve out. So the technique of completing a square is very important in this case. It's not easy to solve such quadratic equations using the technique of factorization. What kind of quadratic equations? Those which has got um, irrational solutions and even complex solutions. And hence a technique of completing the square is very important, as we can solve any quadratic equation using this technique. There are important operations we need to know in this session. One of the properties which we have seen it already in the previous lesson is distribution properties. For a variable x and a constant a x plus a, the whole square is x plus a multiplied by x plus a. That we know it, we have said it before, which is x into x plus a into x plus a, which is x squared plus xa plus ax plus a squared. Xa and ax are the same thing. You have 1a, 1x, 1a, 1x, that's all. So x squared plus 2ax plus a squared. So x plus a, the whole square, is equal to x squared plus 2ax plus a squared. The same thing, we can also reverse this process. We come up this way. We can also go that way. The completing square technique is nothing but the reverse process of this multiplication, such as x plus a the whole square or x minus a the whole square. What is the reverse process of that one then? It's just, let's see it together here. Now what we have here, remember, x squared plus 2ax plus a squared. Here, x squared plus 2ax plus a squared. We start from the final expression and we go in the reverse process. I have x squared here. I split the middle term into two places. Obviously, 2ax means 1ax plus 1ax. That's it. What is 1ax in terms of 2ax? Half of 2ax. 2 cancels out 2, and which is 1ax. So what I do, when I split the middle term, which is 2a, the middle term constant value is 2a. Half of 2a is, just I write it as half of 2a. Here is also another half of 2a. Half of 2a plus half of 2a is 1 half a plus 1 half a, which is just 1 of the 2a, 1 2a. So half of 2a plus half of 2a is 2a. So what we have done, we split the middle term into 2 equal parts, okay? And then the other one, we keep it as it is. So half of 2a is just a. Another one as well, a. So x squared plus ax plus a square. Now, once we have this one, what common term I have here between xx and xa is x. X into xa plus a into xa. X plus a. X into x plus a plus a into x plus a. I need two identical factors here. This one, a technical factorization can give you two different factors. Here, completing a square will give you identical factors. And any x's value will be kept on the other side, which, what I mean, will be explained shortly. So here, x plus a and x plus a, which is x plus a is the whole square. So we can go this way or we can go this way. What we need to remember, take half of the middle term. Take half of the middle term and split it into 2. Half and half of the middle term is exact 1 middle term. That is an important concept here. It is simply the square of x plus half of the coefficient of x. Here can you see, what is this? How can we compare this one with this one? It says x squared plus 2ax plus a squared. 2a, half of 2a is a. Then it is here x and a. Half of the coefficient of x is what we need. All right, next page. Hence, it is just x plus a the whole square. Now, let's do it in numbers. Interesting, very much interesting. Here, x squared plus 6a plus 9. Think of half of 6. Think of half of 6, which is 3. Okay, keep in mind 3. X squared plus 6x plus 9. Now, keep 9 away. We don't need to worry about that now. We don't need to worry about number 9. We need to worry about half of 6, which is 3. So x squared plus 3x plus 3x, I have split it into 2 equal parts, okay? And then what I do? Plus, now this one, once I split it into 2 halves, I need to square one of them. I need to square one of them to add it here on this side. Half of the middle term is 3. 3 square is, here it is, 3 square. Now I added one extra number, which is 3 square. If I add a number in it, I have to subtract the same number right away to maintain the value. So I added this number and I subtract that same number. So this part is nothing but 0. This is helping me for completing the square. Otherwise, number 9 is still there. So I have added nothing here, but I put 3 square minus 3 square. That's just fine. The next thing I do, x into x plus 3 plus 3 into x plus 3. I have taken this part here, this way, here. Now this part is a complete square. A complete square here, which is x plus 3 times x plus 3 is x plus 3 the whole square. what about the other part here? I add also that part, then I will find out the value if there is any. Yes, minus 3 square is minus 9, and then I have a plus 9 here. These two will give me 0. In this case, I get it 0. If I also get it a number which is other than 0, that's just fine. I will put it in the process of completing square, and then we will see what we do after completing square. Let's practice completing square. Once we are okay with the completing square, then we will practice how to solve a solution set of a given quadratic equation using completing square technique. Now what we are doing is we are completing the square. So this is a completing square of x squared plus 6x plus 9. That one. Next example. X squared plus 8x plus 20 is equal to 0. Half of 8, 4. I split it into two places, 4x and 4x. Okay, I have 4 here. What's 4 square? I keep it here. Deduct that same amount, subtract that same amount. But 20 is there already. Okay, I keep it there. Now this part, I will focus on this part, which is x plus 4, the whole square, which is x plus x and x plus 4, the whole square. What about the other part? The other part is minus 4 square plus 20, which is minus 16 plus 20, which is plus 4. I keep it like that. Now I have a square of an expression. This is what I'm interested in. Plus whatever. Plus any constant. Doesn't matter. Because I'm doing now a process of completing square. Let me do the next completing square. 2x squared plus 10x minus 2 is equal to 0. Here I'm going to do a completing square, but I need to see one thing important. Before we complete the square, the leading coefficient has to be 1. The leading coefficient of this expression is the coefficient of the highest degree, which is 2, has to be 1. This is my own technique. As it is, it can be also done, but for simplicity or my preference, I always go with leading coefficient 1. It's much easier. Let's see how we do that. 2x squared plus 10x minus 2 is equal to 0. 2x squared plus 10x minus 2 is equal to 0. Now I divide both sides by 2 to simplify it further to a leading coefficient of x squared to be 1. So it is 2x squared plus 10x minus 2 divided by 2 is equal to 0 divided by 2. 0 divided by 2 is just 0. This one is here. This side, 2x squared divided by 2 is x squared. 10x divided by 2 is 5x. 2 divided by 2 is minus 1. Now I have this one here. I have now the leading coefficient 1, this one. So I can do completing square technique. The second step of a completing square technique, I need to have half of the middle term. Half of 5 is 5 divided by 2, 5 over 2. Okay then, now I split it into 5 over 2x plus 5 over 2x. Now I have to square this part, if you remember. I put a square of that number, half of the middle term, square. I have to deduct that same amount to maintain the balance again. I cannot add extra in this expression other than 0. Then I have a minus 2 here. So this part, I keep it separately, this part here. So the first part here is x plus 5 over 2, the whole square. The second part is here, you can see, minus 25 over 4 minus 1 is equal to 0. Once I simplify this part, I have this one here. So this is completed square, okay? X plus 5 over 2, the whole square, minus 29 over 4 is equal to 0 is a completed square form of the given quadratic equation. Let's see next one. Here I have another property. The previous one is all about x plus a the whole square. The next one is x minus a the whole square. The only difference is this part here. So x minus a square is equal to x square minus 2a plus a square. That's it. Minus 2ax plus a square. In the reverse order, we do the same. X square minus a, x minus a, x minus a square. I take x as x minus a minus a as x minus a, which is x minus a, x minus a, which is x minus a whole square. This is a technique of completing square with x minus a the whole square. Uh, this is what we have done. Nothing much on this. Let's do now to the exact example here. X squared minus 6x plus 4 is equal to 0. When I have x squared minus 6x plus 4 is equal to 0, I do the same thing. First thing, is the leading coefficient 1? The answer is yes. Second thing, I have the middle term. Can I take half of it and split it into 2? Yes. That is this one here. Minus 3x is minus 6x. So I take x minus 3, minus 3, x minus 3. I add 9 here. At the same time, I subtract 9 here. Now that here is 0 is added technically, and 4 is also there before. Now I take 9 on this side, which is x minus 3 is the whole square, minus 9 and plus 4 is equal to 0, which is minus 5. So x minus 3 is the whole square minus 5 is equal to 0 is completed square form of that given quadratic equation. Some more example here. X squared minus 10x is equal to 0. Question 1. Is the leading coefficient 1? Yes. Question 2. Is it in the general format of the quadratic equation? Yes, technically yes. Which is x squared minus 10x plus 0 is equal to 0. Technically yes. So what we do? Can we have half of this middle term, which is minus 5, and the square of it is 25. Keep in mind. Now I need to add 25 and subtract the same value from this expression. So x squared minus 5x minus 5x is equal to 0. This is split into 2. So minus 5 squared is 25 here, this part, and then I subtract 25 that part. Okay, so this part is x minus 5 the whole square. That part is minus 25 is equal to 0 is completed square form of this quadratic expression. Next one, x squared minus 9. Again, is the leading coefficient 0? Is the leading coefficient 1? That is true. Leading coefficient is 1. The other one, difference of two squares, if you remember, we can use here. We have two techniques. One is a difference of two squares. Another one, the completing square. Let's do it with completing square first. X squared minus 9 is equal to 0. What is the middle one here? Is 0x. X squared plus 0x minus 9 is equal to 0. What is half of 0? Is 0. X squared plus 0x plus 0x minus 9 is equal to 0. Now, what's the common term between these two? Which is x. X into x plus 0 minus 0 into x plus 0 minus 9 is equal to 0. X plus 0 minus 9 is equal to 0, or x plus 0 the whole square minus 9 is equal to 0 is the completed square format of this quadratic equation. That's just fine, good enough to say this much at this level. When we go to solve the solution sets of these quadratic equations, we will see more on that. The process of completing square x squared minus 9 is equal to 0 has brought us back to the original question. That means x squared minus 9 is already a completed square form and is known as difference of two squares. That is as follows here. For a variable x and a constant a, x minus a, x plus a, we've said this one in previous lesson, which is x into x plus a minus a into x plus a, x squared plus xa minus ax minus a squared. Xa and ax are the same terms with different sign, then the difference is 0. So we have x squared minus a squared. So x squared minus a squared is equal to x minus a, x plus a. This is one of the definitions of the difference of two squares. Let's do the same for this one. X squared minus 25 is equal to 0. X squared minus 25 is equal to 0. X squared minus root of 25 whole square is equal to 0. Here, 1 half times 2 is equal to 1. Here, x into m and then n is equal to x into m multiplied by n. We have to multiply these exponents together when they come like that. So actually I might have complicated this thing here, probably, but I'm not sure. But just 25 is 5 squared. We have here 25. X squared minus 25 is equal to 0. X squared minus 25 is square root of 25 and square. Here I didn't do anything. Half times 2 is 1. Okay. Then 25 here is 5 square times half, which is already here, times 2. Now I multiply these two, then I will have only this x squared minus 5, this one here, square. X squared minus 5 square is a difference of 2 square, which is x minus 5 and x plus 5 is equal to 0. The product of these two numbers is 0. It means either x minus 5 is equal to 0 or x plus 5 is equal to 0. X is equal to 5 or x is equal to minus 5. It keeps to be like that. Still, we don't need to worry much, but we can have one definition here. For a constant number a, the square root of a means a into an exponent of half. It's just a definition. When we have to simplify, square root of 50, which is 50 into the exponent of half, I have a reason why we have to practice these radicals, because we need to learn irrational numbers at this stage. Some of the solution sets of a given quadratic equation are irrational numbers, is what we say. If it is irrational number, how do we express it? Radicals or square roots. How do we see? How do we do these expressions and all? We need to practice a little bit here. The square root of 50 is 50 into the exponent of half, the power of half. 50 is 2 times 5 times 5. When we have like terms here, 5 and 5, they have a exponent of 1 in each of them. Then 5 to the power of 1 multiplied by 5 to the power of 1 is 5 to the power of 1 plus 1. The exponents will be added, which is 5 square. Okay, I have this one. Very good. Then 2 times 5 to the power of 1 times 5 to the power of 1 itself is 2 times 5 to the power of 2. I have this one. Very good. This another square root here, or the power of half is applied for both. So I can give it to one another. What does this mean? I will explain it here. Let me explain it here. Square root of 2 times 4 is equal to square root of 2 times square root of 4. In case of multiplication, we can divide, but this will work only in case of multiplication and division. But in case of addition and subtraction, we cannot do. Square root of 2 plus 4 might be different from square root of 2 plus square root of 4. In a sense, yes, it is. It is different, okay? There is no such a definition. For a specific number, we can compare and tell if it is yes or no. But in general terms, square root of a plus b is different from square root of a plus square root of b. It's not the same. For only multiplication, ab, we can put a, then b. That's what we get it here. So 2 to the power of half and 5 squared to the power of half. This one, 2 times half is just 1. So we have 5 here. But 2 is still in a square root. So the expression of this square root of 50 is 5 into radical 2. We have just come this way to make it more visible. But it means what? It means square root of 50 is equal to square root of 25 times 2, which is equal to square root of 5 squared times 2. When a number has an exponent of 2, then it can be out of the square root. So 5 into square root of 2. Simply, it is that one. Let's see another interesting thing to simplify. Square root of 49 times 9 times 3. It looks like I'm following here a formal method, but simply square root of 49 is 7, square root of 9 is 3. I have already 21, 7 times 3, but square root of 3 cannot be out, then it remains in the radical symbol. So 7 times 3, 21 here, and then root 3, 21 root 3. It is how we do it. No problem. So in the formal way, 49, 9, 3. 7 squared, 3 squared, 3. 7 squared, 3 squared, 3. All in the power of half. 7 squared and a half. This is 1. This is 1. This is a square root of 3. Because the exponent is still half. So 3 will be in the radical symbol. In the other one, 7 times 3 will be 21. Let's see what's next. Here's one definition. For a variable x and a constant number a, if x squared minus a is equal to 0, then x squared is equal to a. Or if x squared is equal to a, x is equal to plus or minus a. Why? That's because x can be minus a times minus a. Negative multiplied by negative is positive. Then simply this one. So it's a plus a. Another one, plus a times plus a is the same again. Plus a. So x squared minus a is equal to 0. X squared is equal to a. X is equal to plus or minus square root of a. This is there, but there is one confusion in most cases. What is the square root of 9? Which is exactly 3. There is no plus or minus 3 in this case. The square root of a number, in fact, the square root of a positive number, because there is no possibility that a square root of in a square root we put a negative number. We don't put like this, which is not defined. But the square root of a number, say 9, is equal to 3. It's only a positive value we have to take. It is the definition of absolute values is there. We can only take the positive value. If we say x squared is equal to 9, x can be a plus or a minus 3. That is true. If the square of a number is 9, that number can be a positive number square or a negative number square. That's true. But when we are given a number, say, what is the value of square root of 25? We are already given the value here. We are already given that 25 is a positive number in a square root, which is just 5. Always positive. Let's see here. Now this continuation is from here. X squared is equal to 5, okay? X squared is equal to 5. X is plus or minus square root of 5. Is there a plus or a minus part of the square root of 5 is true. It is true that the square of either a positive number or a negative number is always positive. That's why we have to take either the positive part or the negative part. Let's solve this one again. X squared minus 18 is equal to 0. X squared is equal to 18. X is equal to plus or minus 18. But 18 is what? 2 times 9. So 9 can be freed because it is 3 square. So 3 is out and then still 2 under the square root or radical. This is here. But it is a plus or a minus because x squared is equal to 18. X is equal to plus or minus square root of 18, which is this one here. Either this one or this one. Next one. X squared plus 9 is equal to 0. X squared is equal to minus 9. The square of a number is minus 9, which is not possible. The square of a number is always positive. Then x is equal to whatever plus or minus, but the square of negative, and still not possible. So what we have, there is no such x value to satisfy this equation. Here the square of a real number cannot be negative. Actually, the square of a real number is an important term here. Cannot be negative. But there is a number which satisfies this expression, and that number is a complex number. I can solve that one so that when we see it later on, we understand what it is. No problem. Hence, there is no real solution set. What is a complex solution set? We have mentioned this one in the previous lesson. X squared is equal to minus 9. X is equal to plus or minus square root of minus 9, which is equal to plus or minus square root of minus 1 times 9. Minus 1 times 9 is minus 9, that's true. Which is equal to plus or minus square root of minus 1 and square root of 9. Square root of 9 is 3. A square root of minus 1 is I or iota. So it is 3i or minus 3i. We can say that. Doesn't matter. But this is in the complex number system, not in the real number system. However, we can still solve this equation in the domains of complex number as follows. Okay, we have it here already. So it is solved up here. Same thing I just try to explain up. Note 5. A complex number, z, is a number defined as for real numbers a and b, and an imaginary number called iota, where the value of iota is I, square root of minus 1. Z is equal to a plus b into I. So there are two real numbers here. One is a, another one is b, which is connected to I. In the previous example, where x is equal to plus or minus 3i, the standard form of plus or minus 3i, which is a complex number, can be 0 plus 3i or 0 minus 3i. Here, a is equal to 0 in the standard form of a complex number, which is a plus bi. A can be 0, then we don't need to mention a, we simply put bi, which is 3i or minus 3i here. For a complex number z, which is 3 plus 4i, the polar representation can be as follows. This side magnitude is 3, this side magnitude is 4, this is at 90 degrees. The x-axis 3, in the y-axis weight, and 4. The radius of this the polar here, by Pythagoras theorem, 3 square plus 4 square in a square root, which is square root of 25, which is 5, doesn't matter. But this one is z is equal to 3, which is the x side, plus 4, which is the y side, then iota. Solve the following quadratic equations using completing square technique. Now let's do again more and more completing square. Yeah, we remember that. Let's do a completing square technique with given pieces of information which we have seen now. X squared plus 2x minus 6 is equal to 0. We take the first question. Is the leading coefficient 1? The answer is yes. Good. Now, what is half of the middle term? The whole is 2x, half of it is x. This part, the leading coefficient of x is 2, half of it is 1. Then we need to square 1, and then 1 square is 1, okay? So here x squared plus x plus 1, which is 1 square. And because we added 1 here, we need to subtract 1 here. And then originally we have minus 6 here. That's it. Once we set up this, the rest of the things are so easy. So here we have x, and x. Take 1x and x plus 1. Put x plus 1 here and 1 here. This is x plus 1, the whole square. Okay? This part, minus 1 minus 6 is minus 7. So x plus 1 the whole square is equal to minus 7. X plus 1 the whole square, minus 7 is equal to 0, this part. X plus 1 the whole square minus 7 is equal to 0. When we move 7 in the other side, by adding a plus 7 on both sides of the equality sign, we simply change the sign of negative here into positive. X plus 1 the whole square is equal to 7. It's interesting that the square of a certain expression in real number system has to be positive, and we have a positive. Oh, very good. When we don't have this part a positive, it looks like that's a complex solution. Let's see now. So we put it in a radical of both sides. X plus 1 the whole square in a square root is equal to 7 plus or minus 7 in a square root. Okay? X plus 1 is equal to plus or minus square root of 7. X is equal to, here I have a minus 1 plus or minus square root of 7. Minus 1 plus square root of 7 is one part. Minus 1 minus square root of 7 is the other part. So the two solution sets of this quadratic equation is, by completing square, two real solutions. One is minus 1 plus square root of 7. The other one, minus 1 minus square root of 7. Such two numbers, when you multiply, the sum of the two numbers and the product of the two numbers is stories, which is in factorization technique. It's not possible for solution sets of such equations, So this completing a square is a technique that can solve any kind of quadratic equations, and even the general form or the general equation of a quadratic equation is derived from this technique, and then we will do that. Let's do another example here. X squared minus 3x minus 2 is equal to 0. Is the leading coefficient 1? Yes, good. What is half of minus 3? Minus 3 over 2. What about the square of that number? 9 over 4. Good, job done. So x squared minus 3 over 2x minus 3 over 2x plus 9 over 4. At the same time minus 9 over 4 to balance it to 0. Then minus 2 is there in the original equation. That's it. So this is x minus 3 over 2 the whole square is equal to what we have here. It looks very long, but doesn't matter. The whole thing is that x minus 3 over 2 the whole square minus 17 over 4, which is, where is 17 over 4? This one here, minus 9 over 4 minus 2, whatever. This is it. Now, x minus 3 over 2, the whole square is equal to 17 over 4. Then x minus 2 is equal to plus or minus square root of 17 over 4. That's the thing. Then x is equal to, take this one on the other side, 3 over 2 plus or minus 17 over 4. It's not a big deal, but if you think it is, just you pause and check each and every step. Now the two solution sets are real solution sets, and these are the one. Let's go for the next completing square. 4x squared minus 12x plus 9 is equal to 0. Is the leading coefficient of x squared 1? No. So what we have to do, divide both sides by 4. Here it is. Divide both sides by 4. What we will have on the left side? 4 by 4 is 1. 12 by 4 is 3. 9 by 4, we keep it as it is. 0 by 4 is 0. So that what we have is this one. Very good. The next thing. Now we have arranged it to leading coefficient of 1, which is the number one thing we have to do. Number 2, we made sure that the expression is in the general quadratic equation formula format. That we prove as well. Once we have these conditions satisfied, the next thing we do, let's take the middle term and half of it. Half of it is half of minus 3, which is minus 3 over 2. Keep that one. Square it, 9 over 4. Keep that one. These are two important numbers. The next thing is x minus 3 over 2 the whole square. X minus 3 over 2 the whole square. This one, we square it, right? And we got 9 over 4. We need to add 9 over 4 and to subtract 9 over 4 at the same time. Here we add, here we subtract. This 9 over 4 is originally there. So what we have now, these two, the minus 9 over 4 plus 9 over 4 comes to be 0. And this 9 over 4, we need it on this term, on the completing square side. X minus 3 over 2, the whole square is 0. That's good. X minus 3 over 2 is plus or minus square root of 0 is plus or minus 0. It is just 0. Okay? What's the next thing then? X is equal to the other side of the equality sign. 3 over 2. We change the sign here to positive. Okay? This is only one solution set, and it is 3 over 2. How we do this one? We just add 3 over 2 here. The other side of the equality sign, the same, we add 3 over 2, and this side cancels out. We can say that. So this equation has only one solution set, which is 3 over 2. And it is a real solution set. It's not a complex solution set. We will have examples of a complex solution set later on, and we will see that one. Another equation is up here to find out a solution set by completing square. Is the leading coefficient 1? No. So what we have to do, divide both sides by 3. This part, okay? Once we divide, what we have, leading coefficient 1. Good. Middle term 5 over 3 negative, good, and 1/3. We divide both sides, means each and every expression has to be divided by that same number. So we have this general format of this quadratic equation. That's important thing. What is half of the middle term? Which is half of minus 3 over 2, which is minus 6 over 2, good. What is the square of that? Which is 25/36. Now we have all the required things for a completing square. So we just put them all together like that. Then basically x minus 5 over 6. The whole square is equal to this part and that part, as we have done it before. We add the other part. To add the other part here, I have minus 25 over 36. Here I have 1 over 3. Because these two numbers are different in the denominators, we cannot add the numerators. We have to make sure this denominator is the same as this denominator. So for 3 to be the same as 36, we need to multiply that with 12. When we multiply the denominator here by 12, the same number we have to multiply the numerator by 12. So this one is what? Minus 25 over 36 plus 12 over 36. Now we can put the numerators all together here with a common denominator here. So x minus 5 over 2 the whole square minus 13 over 36 is equal to 0. Move this one to the other side of the equality sign. X minus 5 over 6 is plus or minus square root of 13 over 36. X is equal to 5 over 6 plus or minus. Plus or minus. The square root of 36 is just 6. That's why it's here. So these are the two solution sets of this quadratic equation. Next question, or next example. X squared plus 4x plus 53 is equal to 0. Is the leading coefficient 1? Yes, that's good. Is this expression in the general format of a quadratic equation such as ax squared plus bx plus c? Yes, that's in the correct order. Good. What is half of the middle term? Which is half of 4? That's 2. Okay. What is the square of half of the middle term? Which is 4. Good. Now we have these two numbers. Now we are in a very good setup. X squared plus 2x plus 2x, you split the middle term, plus 4, add this one here, minus 4, subtract at the same time to maintain the balance, and then 53 is equal to 0. Job done. X into x plus 2 plus 2 into x plus 2, which is x plus 2 the whole square here, plus 49 is equal to 0. Next. Now x plus 2 the whole square plus 49 is equal to 0 means x plus 2 the whole square is equal to minus 49. The square of a certain expression is negative. In a real number system, we don't have such a thing. So the solution set for this has to be either complex number, or we can say there is no real solution. Okay, there is no real solution. Good. Is there any complex solution? Yes. Can we solve for it? Yeah, we can solve. It is clearly seen that the square of a real number, x plus 2, cannot be negative. Therefore, there is no real solution. However, we can proceed to find out the complex solutions. Let's do that one. Now, where we are here, x plus 2 the whole square is equal to plus or minus square root of minus 49. X plus 2 is equal to minus 49 is minus 1 times 49. Now let's split this radical into 2. In multiplication, yes, we can do. 49 is 7 minus square root of minus 1 is iota. So we have plus or minus 7i. That is a solution set for it. But it is a complex. But what is that? X plus 2 is plus or minus 7. I. Are we solving for x plus 2 or are we solving for x? We're solving for x. So x plus 2 is plus or minus 7 iota. Then x is equal to 2 plus 7 iota or 2 minus 7 iota. That's it. The two complex solutions are these ones. This is an exercise. The total area of the square of side 2x plus 3 2x plus 3 is 16 units. That side also 2x plus 3. Total shaded part is 16 units. Find the side of the large square using completing square. The side of the large square. We have two squares. One is this one. This is a large square. Because we have another small one here. Not, we can say medium one, but doesn't matter. We are asked to find out x. And then we put the value of x in place of 2x and then add 3. That's the side of the square. So this is exercise just to be left for you to practice. Another exercises are there to practice more. Solve the following equations. Use equations and check the correctness of the answers by substituting the answer into the original equation, because I don't put an answer for this one. So you just yourself can check the correctness by substituting the answer. One such example we can do if required. Let me just randomly take this one. 6x squared minus 4 is equal to 16. 6x squared minus 4 is equal to 16. No worries, I can do it here. 6x squared minus 4 is equal to 16. Here, these two are constants. Then I bring 16 in this side. 6x squared minus 4 minus 16 is equal to 0. 6x squared minus, it is 20, is equal to 0. Now, here 6x squared minus 4 is equal to 16 is 6x squared minus 20 is equal to 0. The leading coefficient is not 1. So I need to divide both sides by 6. Okay? So x squared minus 20 over 6 is equal to 0. X squared. I can not much to worry on this one because we don't have the middle term. The middle term is 0. So I can use x squared, the difference of two squares I can use. Or I can simply say x squared is equal to 20 over 6. I can see the square of a number is positive and I have a positive value there. So I can have two real solutions. Okay, x is equal to plus or minus square root of 20 over 6. That's the value of x. Okay, I have two x values. One is square root of 20 over 6. Another one minus square root of 20 over 6. I can put these values here and check if I am correct or not. 20 over 6 in a square root, when you square that one, it is 20 over 6. So here, 6 times 20 over 6 minus 4 is equal to 16. This cancels out. 20 minus 4 is equal to 16. Then 16 is equal to 16 is true. The same is true for the negative part of this one, because when I square it, it gives me positive. Such and such a thing. You solve it and then you put the answer in the original equation and find out. You end up with a true statement, and that's just fine. Even this works for a complex solutions. When you have a complex solutions, you can still substitute the complex solutions in terms of variable x, and then you keep doing it. You will find out the result to be true. Normally in iota minus 1, you can multiply such a thing like, again, radical square root of minus 1, which is square root of minus 1 times minus 1, which is square root of 1, which is 1. That means iota by iota is 1, and something like that. you can still use it like a normal expression, even though it's a complex number. It's not complex at all. It is much simple to work with. So we have 55 minutes now. The next thing is solving quadratic equations using quadratic formula. That formula is derived from completing square technique. That's what we've said it here. The same thing, we do the leading coefficient to be just 1, so we have to multiply both sides by a. We have to divide both sides by a, or we have to multiply both sides by 1 over a whatsoever. So we can bring the equation in such a way as x squared plus b over ax plus c over a is equal to 0. We do this and that. Instead of just using a number and getting the answer, we try to find out a general formula for a quadratic equation in terms of constants a, b, and c. So these are the things. And then after that, can we find out the sum of the squares, the difference, not the difference, the product of the squares. The average, we can get out the average of the roots. The average of the roots, we can find out. The sum of the roots, we can find out. The product of the roots of an equation, we can find out without solving the equation, by taking only the constants a, b, and c. In such cases, one real solution in such cases here, x is equal to minus b over 2a here. You can see that's for what? That's for what? Given here a general quadratic equation formula, the numbering type of the solution sets are purely depend on the values of b squared minus 4ac. The discriminant parts of this quadratic equation, we call it. Anyway, a lot more to discuss, but it's not part of this lesson. The next one is using a completing square, we can derive the general formula, the sum of roots minus b over a, the product of roots c over a. If we need the average of the roots, minus b over a divided by 2, which is minus b over 2a. Such and such formulas we can derive, okay? Then for now, thank you for attending. Just don't forget to subscribe this channel for more videos to come up, and have a good time. Thank you.